Hi, welcome to the first part of this lecture on superposition. My name is Hania Malik Jafarian and I'm a member of Pattern Recognition Lab at Ferdowsi University of Mashhad. In this lecture, we are going to talk about superposition theorem, one of the most powerful tools in circuit analysis. We'll start with a quick overview of what superposition is and why it's so useful. Then we walk through a step-by-step guide on how to use it. To bring it all together, I am going to show you a simple DC circuit example to demonstrate how superposition works in action. So let's get started. Analyzing circuits with multiple sources can be tricky, especially for complex designs. While methods like nodal and mesh analysis are effective, they can become difficult to apply when dealing with several independent sources. The superposition theorem simplifies this process by breaking the circuit down, making it easier to analyze each source independently before combining the result. So what is superposition? The superposition theorem states that in any linear network that has more than one source, you treat each independent source as an individual, and then calculate the voltage or current that it has on the circuit and combine the result together. It's like solving a puzzle, where each independent source in the circuit contributes a piece to the solution. Instead of solving the entire puzzle all at once, we'll look at each piece source separately, figure out its contribution, and then combine them together to see the full picture. Let's take a look at this equation here. This represents the total current or voltage in the circuit, and this one represents the sum of the individual contributions from each independent source. Let's see a step-by-step guide to help us go through questions more easily. Step 1. Identify all the voltage and current sources in the network. Step 2. For each independent source in the original circuit, create a new subcircuit. The subcircuit will be identical to the original, except that all independent sources other than the one under consideration will be replaced by their ideal internal impedance. This means that all remaining independent voltage sources will be shorted, act as a wire, and all remaining independent current sources will be opened, act as a break. Step 3. Solve each subcircuit. Now you have a circuit including only one source, so you already know how to solve that. Step 4. Repeat these steps for all the other sources. And the last step is to combine all the contributions from each subcircuit to determine the final values. Make sure to consider the current directions and voltage polarities throughout the process to ensure accuracy. Let's take a look at this example. It's a DC circuit and it wants us to find the voltage across 2 ohm resistor. So the first step was to identify the sources in the circuit. We have 2 sources here, a current source and a voltage source. Then we choose one of them. I want to start with the voltage source, but you can start with either. So if I start with the voltage source, I have to replace the current source with its ideal internal impedance, which is infinite, so it will act as an open. Now we have a simple circuit and we can use voltage division to calculate the voltage across 2 ohm resistor, so let's just call it V01. This is a ground, this will be V01. V01 is equal to 2 cross 10 divided by 2 plus 3 plus 5, which equals to 2 volts. Now I have to do the same for the current source. So in here, I keep the current source and replace the voltage source by its ideal internal impedance, which is 0, so it will act as a wire. Now we have a 4 amp that is getting divided between these 2 branches, and because their resistance are the same, so the current through 2 ohm resistor will be 4 divided by 2, which is 2 amp. And using Ohm's law, let's call it V02 is equal to 2 cross 2, which is 4 volt. The last step was to combine all the results together, so V0 is equal to V01 plus V02, which is 2 plus 4, which equals to 6 volt. Thank you for watching, and you can access my project by scanning this QR code.